On the 17th of August, 2026, GitHub stopped working for 7 hours and 47 minutes. At the worst of it, roughly 1 in 5 requests to the website and the API failed outright. Roughly half of all archive and raw content downloads failed. Authentication broke, pull requests broke, actions broke. And to bring it back, GitHub's engineers did something worth sitting with for a moment. They went to their load balancers and they started answering their own artificial intelligence product with a 403. Access denied. That is not a rumor. It is in GitHub's own root cause analysis, published on their own status page in their own words. Here is my thesis, and everything that follows is an argument for it. GitHub is the largest running experiment in agentic software development anywhere on Earth, and the most honest telemetry that experiment produces is not in the launch posts. It is in the incident reports. The launch posts sell you a number. The incident reports tell you what that number costs. So for the next half hour, I am going to read GitHub's own 2026 documents in the order they were published: the product announcements, the monthly availability reports, the postmortems, the status page. Every source is GitHub describing GitHub. And together they tell a story that not one of them tells on its own. It starts with a number that doubled. Chapter 1, 7 hours and 47 minutes. Let us start with what actually broke, because the mechanism matters more than the outrage. GitHub's root cause analysis gives the window precisely. From 1328 to 2115, Coordinated Universal Time on the 17th of August. 7 hours and 47 minutes. The list of affected services is long. Issues, pull requests, the APIs, actions, Copilot, enterprise single sign-on, team synchronization. Even actions workflows running inside customers' own data-resident enterprise environments, because those workflows reach back to public step definitions hosted on github.com. At peak, GitHub says web and API error rates were approximately 20%. Archive and raw content downloads reached approximately 50%. Now the chain of causation, and I want to walk through it slowly because this is the part that gets summarized away. The immediate cause, GitHub says, was network saturation on load balancers in their central US data center, due to a new peak in traffic. That saturation began with a single component. An Istio sidecar pod hit its concurrency limits. Istio is a service mesh. A sidecar is a small proxy that sits next to each service and handles its network traffic. That sidecar should have scaled up automatically when it got busy. It did not. Why not? Because of what GitHub calls a misconfigured policy that watched host service but not sidecar limits. The autoscaler was looking at the wrong number. It was watching the application and ignoring the proxy standing in front of it. So the proxy filled up while the dashboard said everything was fine. And then it cascaded. One failure led to more, and eventually 4 HA proxy nodes exhausted their flow limits. HA proxy sits in front of the whole thing. When those 4 nodes ran out of capacity, the gateway authentication path degraded, and that is when authentication started failing for everybody. Read that sequence again. A mies-scoped auto-scaling rule on a sidecar took down login for the world's largest code host for the better part of a working day. And here is the sentence in GitHub's analysis I keep coming back to. Quote, "The problem was worsened by optimistic retry logic which overloaded internal load balancers." Optimistic retry logic. Software that, when it fails, tries again immediately, because trying again is usually cheap and usually works. Hold that phrase. In the next chapter it stops being a footnote and becomes the story. Chapter 2, the Retry Storm. Most services came back by 1636 UTC when the central US data center recovered. Actions stayed degraded until around 1803, but one service did not fully recover until 2102, almost 4.5 hours after the rest of the platform was healthy. That service was the Copilot Token Service, the thing that issues the credentials letting an AI coding assistant talk to GitHub. Here is what GitHub says happened to it. I am going to quote this exactly because paraphrase would soften it. Quote, "Delayed replies to a single internal endpoint triggered a latent retry bug in V's code that amplified traffic by approximately 10 times and caused delayed recovery for the Copilot token service. One internal endpoint got slow, not down slow. And a dormant bug in Microsoft's Visual Studio Code, the editor GitHub's own Copilot ships inside, turned that slowness into a tenfold traffic multiplier. GitHub then gives us the raw figure, and this is the single most valuable number in the whole document. Quote, Copilot Token Service traffic increased from a normal 7 to 9,000 requests per second to 70 to 100,000 requests per second. 7 to 9,000 normally, 70 to 100,000 during the incident. That is roughly a tenfold increase in load on a service that was already struggling, generated not by users and not by attackers, but by the client software the vendor ships. And notice the shape of it. The service was slow, so the clients retried. The retries made it slower, so the clients retried more. GitHub describes it plainly. A failed token operation could generate many extra requests and enter a retry loop. That is a positive feedback loop with no break. In a distributed system, that is not a bug you patch. That is a design property you have to actively suppress. So how did they stop it? Two things per GitHub. First, they temporarily reduced gateway retry logic shipped as a pull request during the incident. Second, and I quote, blocking inbound Copilot Token Service token requests at the load balancers with a 403, and then gradually ramping backup traffic per site to allow callers to succeed. They served access-denied errors to their own AI product, deliberately, at the network edge, because the alternative was that the AI product would not let the platform recover. And then quietly in the list of follow-up actions, this line, addressing the VS Code retry behavior that amplified Copilot token traffic. An open item. As of the 17th of August, the amplifier was still in the field. There is one more detail I will not let slide past because it is a genuine complication and leaving it out would flatter my argument. GitHub also notes, quote, complicating factors that impeded recovery included a number of scraping attacks on code load endpoints. Scrapers made it worse too. Both things are true. Chapter 3, The Number. 3 days after the outage on the 20th of August, GitHub's Chief Technology Officer, Vlad Fedorov, published a post on the company blog titled The August 17 Outage and the Work Ahead. It is a short post, 4 minutes by its own estimate, and buried in the middle of it is a sentence that got more attention than the rest of the post combined. Quote, since April, monthly commits have grown from 1.4 billion to 2.9 billion. That growth explains the pressure on our systems, but it does not excuse these outages. Stop and hold that, 1.4 billion commits a month in April, 2.9 billion commits a month by August. That is slightly more than a doubling in roughly 4 months. Now, where did the 1.4 billion come from? It came from GitHub, specifically from a post published on the 2nd of June 2026 by Mario Rodriguez, GitHub's Chief Product Officer, announcing the GitHub Copilot app at Microsoft Build. The post is titled, and I am not editorializing here, The Agent-Native Desktop Experience. In that post, Rodriguez writes, quote, on GitHub alone, commits nearly doubled year over year, crossing 1.4 billion per month, plus over 2 billion GitHub Actions minutes a week. So the same number appears twice in GitHub's 2026 output, 11 weeks apart, doing two completely different jobs. In June, it is evidence. It is the proof point in a product launch. Look how much more software is being written. Come and buy the agent-native desktop experience. In August, it is load. It is the thing that explains why the platform fell over. Neither statement is false. Both are GitHub's own, and I want to be careful here because it would be very easy and very cheap to call this hypocrisy. It is not hypocrisy. A chief product officer and a chief technology officer are supposed to look at the same number and see different things. That is the job. What I am pointing at is subtler and more interesting. It is that between June and August, the growth rate itself changed character. Watch the arithmetic. In June, Rodriguez says commits nearly doubled year over year to reach 1.4 billion a month. Year over year, 12 months to double. In August, Fedorov says that same 1.4 billion became 2.9 billion since April. 4 months to double. The doubling time collapsed from about a year to about a third of a year. That is not the same trend continuing. That is the trend accelerating, and GitHub reported both halves of it in public without ever putting them side by side. Which raises the obvious question, what is generating the extra 1.5 billion commits a month? GitHub's August post does not say, not once, The words AI, agent, and Copilot appear nowhere in its explanation of the growth. But GitHub has answered that question, just not in August. Chapter 4: What the Chief Technology Officer Said in April. Go back 4 months to the 28th of April 2026. Same blog, same author Vlad Fedorov, Chief Technology Officer, a post titled An Update on GitHub Availability. It was written after 2 other incidents, a merge queue failure on the 23rd of April and an Elasticsearch outage on the 27th. And it is, I think, the most candid document GitHub published all year. It opens by apologizing, quote, "Both of those incidents are not acceptable and we are sorry for the impact they had on you." Then it gives the capacity numbers, and these are extraordinary. Quote, "We started executing our plan to increase GitHub's capacity by 10 times in October 2025, with a goal of substantially improving reliability and failover. By February 2026, it was clear that we needed to design for a future that requires 30 times today's scale." Read that again slowly. In October, they set out to build 10 times the capacity. By February, 4 months later, they concluded that 10 times was not enough and the real target was 30 times. Now why, in April, Fedorov answers directly, quote, "The main driver is a rapid change in how software is being built. Since the second half of December 2025, agentic development workflows have accelerated sharply." There it is, named by the Chief Technology Officer in writing, agentic development workflows. He goes further, listing what is growing: repository creation, pull request activity, API usage, automation, and large repository workloads. And then he writes a sentence in April that describes the August outage with uncomfortable precision. Quote, "At high scale, small inefficiencies compound. Queues deepen, cache misses become database load, indexes fall behind, retries amplify traffic, and one slow dependency can affect several product experiences." Retries amplify traffic, and one slow dependency can affect several product experiences. That is, almost word for word, what happened on the 17th of August. One slow internal endpoint, retries amplifying traffic tenfold, several product experiences affected. GitHub's Chief Technology Officer wrote down the failure mode 111 days before it took the platform down for the better part of a day. I do not say that as a gotcha, I say it because it changes what the August outage means. This was not a surprise, it was not an unknown unknown. It was a named, published, understood risk that the company was in the middle of racing to engineer around, and the growth curve got there first. The April post is a company saying, "We know what is coming, we are rebuilding the aircraft in flight, and we may not finish in time." They did not finish in time. Chapter 5: The Word That Disappeared. April was not the only time GitHub named the cause. On the 11th of June, 2026, GitHub published its May availability report, and it contains what I would call the cleanest single-sentence statement of the whole situation that the company has ever made. Quote, "GitHub's traffic is growing rapidly, driven in large part by AI-assisted and agentic development workflows, and we've been transforming our infrastructure to keep up with it." Driven in large part by AI-assisted and agentic development workflows. GitHub's own words in a document about reliability published under the company's name. So the attribution exists. It is on the record twice, the Chief Technology Officer in April, the availability report in June. Now go and read the August 20th post again, the one about the biggest outage of the year, and count how many times it names the driver. 0. What it says instead is this, quote, "Since April, monthly commits have grown from 1.4 billion to 2.9 billion. That growth explains the pressure on our systems." That growth, passive, sourceless, agentless. Growth as weather, something that happens to a company rather than something a company's own products are causing. Now, is this sinister? I do not think it is sinister. I think it is something more ordinary and more instructive, a company writing an apology and choosing not to hand its critics a headline. If your Chief Technology Officer writes, "Our AI products generated the load that broke us," that sentence leaves the building and it never comes back. But look at the cost of the omission. The April post, which names agentic workflows, is a document you can act on. It tells you what is happening to software development, why the capacity target tripled, and what the failure modes will look like. If you run infrastructure anywhere near this ecosystem, that post is genuinely useful to you. The August post, which does not name it, is a document you cannot act on. It tells you a number went up and the company is buying hardware, 3 million CPU cores, 120 petabytes of high-speed storage, 58% of platform load now on Azure, up from 12% in May. Those are impressive figures and they are answers to the wrong question. They tell you how GitHub is absorbing the wave. They tell you nothing about what is making the wave or whether it stops. And here is why that matters beyond GitHub. Every company running a developer platform right now is trying to forecast the same curve. GitHub is the only one with a complete view of it. When GitHub publishes the number but withholds the mechanism, everyone else is left extrapolating a line with no model underneath it. The most useful thing GitHub knows is the thing it stopped saying out loud. Chapter 6: What is a commit actually worth? Now I want to attack my own Chapter 3, because a number that doubles is only interesting if you know what it counts. A commit is the smallest unit of recorded change in Git. It is a snapshot with a message attached, making one costs nothing. You can commit a typo fix. You can commit a whitespace change. An automated tool can commit a dependency bump 1,000 times a day across 1,000 repositories, and every one of those is a commit. Crucially, a commit is not a merge. It is not a release. It is not working software. It is the cheapest thing a developer or an agent can produce that still shows up in a chart. So what did GitHub count before it started counting commits? Go back to Octoverse, GitHub's annual research report published on the 28th of October 2025. It contains a table of monthly averages and the row I care about is labeled code pushes. 2024, 65 million a month. 2025, 82.19 million a month. A push is a batch. When you send your work to GitHub, that is one push, and it may carry one commit or 50. Now here is something I checked rather than assumed, and I think it is worth showing the working. The pros in that same Octoverse post says, quote, code pushes are driving the surge with more than 986 million commits in 2025. 986 million called commits. But multiply the table's own monthly average, 82.19 million, by 12 months. You get 986.28 million, an exact match. So the 986 million figure is the annual total of pushes, and GitHub's own sentence labels it commits. In the company's flagship annual research report, it is a small slip and I do not think it was deliberate, but it tells you how loosely these two units get handled, even by the organization that owns the database. And that matters for the headline number because between October 2025 and June 2026, the unit GitHub leads with changed. Octoverse led with pushes. The Copilot launch post led with commits. The outage post led with commits. Commits is the bigger number. Roughly 82 million pushes a month in 2025, against 1.4 billion commits a month by April 2026. That would imply something like 17 commits per push. Is that possible? Yes, genuinely. Agents commit in small increments. That is how they are built to work, and a stacked series of tiny commits inside one push is completely normal machine behavior. So I am not claiming these numbers contradict each other. I am claiming something narrower and I think harder to argue with. GitHub has published no methodology for the 1.4 billion or the 2.9 billion. No definition, no breakdown by human versus automated author, no commits per push ratio, nothing. The most quoted statistic about the agentic era comes with no methods section at all. And GitHub knows this is a problem because Octoverse says so itself. The report's own caveat reads, quote, "These are observational signals rather than causal claims, and more work is needed to understand the full impact AI is having in software development." That is GitHub's research team being properly careful. 8 months later, the product organization was using the same class of signal as a proof point in a launch. Chapter 7: Nobody is reading it. If code volume roughly doubles, one of two things has to be true. Either the human capacity to review that code doubled alongside it, or it did not, and the surplus is going somewhere. GitHub measured this in 2025 and published it. Back to that Octoverse table of monthly averages, and this time the whole thing. Issues closed, up from about 3.4 million to 4.25 million. Pull requests merged, up from 35 million to 43.2 million. Code pushes, up from 65 million to 82.19 million. Production across the board, up roughly 20 to 25% in a year. Now the other rows, which got far less attention. Comments on issues and pull requests, essentially flat. GitHub's number is plus 0.35%. Comments on commits down 27%. GitHub's own word for it in the report is sharp decline. So in the year that code production rose by a quarter, the volume of human commentary attached to that code stayed flat, and one specific form of it fell by more than a quarter. More code, the same amount of conversation about it, less line-by-line remark on the commits themselves. I want to be honest about what that does and does not prove, because this is exactly the sort of statistic that gets overread. It does not prove code quality fell. Comment counts are a crude proxy for review, and there are innocent explanations, review moving into the pull request and out of the commit thread, or into tools that do not leave a comment at all. Octaverse's own caveat applies here with full force. Observational signals, not causal claims. But there is a second GitHub document, and this one is not a proxy, it is a description. On the 4th of August, 2026, GitHub's engineering blog published a post about breaking large AI-generated pull requests into reviewable stacks. It walks through a worked example. You give a coding agent a feature, you walk away, and you come back to a diff. The post's own numbers: a 1,000-line plus diff in the general case, and 1,721 lines changed in the specific example. The post even writes the reviewer's reaction in character: 1,721 lines changed. This description isn't very helpful, I'll review this later. And then GitHub says what happens next. Quote, the large pull request becomes hard to review, so it just sits there. Reviewers lose context and the feedback quality drops. It becomes even slower to merge. And the conclusion, which is the sentence I would put on the wall, it eventually lands under-reviewed. That is not a critic. That is not a disgruntled engineer on a forum. That is GitHub's engineering blog describing the default output of the product GitHub sells in a post whose entire purpose is to help you cope with it. One more from the same company 3 weeks earlier. On the 17th of July, Dalia Abuadas, a software engineer on GitHub's Copilot Agent Control Plane team, published a piece called "The Cost of Saying Yes Has Changed." It is a thoughtful pro-agent argument. She is not against any of this, and she draws the line exactly where it belongs. Quote, a change is not cheap just because the code was cheap to generate. It's cheap only if a human can confidently review and own the result. And then, AI lowers the cost of producing a candidate. It does nothing to lower the cost of owning one. 2.9 billion candidates a month. The cost of owning them has not moved. Chapter 8, The August Ledger. So far I have been reading GitHub's essays. Now let us read GitHub's receipts, the status page, which is not written for persuasion. It is written because enterprise contracts require it. I pulled GitHub's public incident feed on the 22nd of August, 2026. Between the 1st and the 20th of August, GitHub recorded 18 incidents. 18 in 20 days. Of those 18, 7 name Copilot, a specific AI model or agent tasks directly in the incident title, degraded availability of one model on the 1st. Copilot AI model providers also the 1st, an incident with Copilot on the 3rd. Copilot Cloud agent jobs not starting on the 5th. Copilot losing access to some models on the 10th. Errors with another model in Copilot on the 13th, and failures creating agent tasks on the 20th. 7 of 18, roughly 40% of GitHub's publicly recorded August incidents were AI-serving incidents. I want to be careful with that number rather than let it do more work than it can bear. Most of those 7 were rated minor. Several are upstream model providers having a bad day, not GitHub breaking. And an incident count is a count of disclosures, not of severity or of hours lost. GitHub's own monthly reports count differently again: 10 incidents reported in April, 6 in June, 8 write-ups in July, so you cannot lay the status page tally next to the blog tally and call it a trend. I checked, and I am not going to pretend otherwise. But 3 of August's 18 were rated critical, GitHub's highest severity, and it is worth naming all 3. The 6th of August, an incident with actions. Opened 1522 UTC on the 6th, resolved 0204 UTC on the 7th, 10 hours and 42 minutes. GitHub's July availability report published on the 12th of August opens by calling it, quote, unacceptable in both its impact and particularity of its duration, and adds, we have fallen short of our commitments to you. The 17th of August, the outage this whole video has been about. And the 20th of August, intermittent failures creating agent tasks, critical severity, opened at 14:43 UTC. Now put one more timestamp beside that. Vlad Fedorov's post, the one titled The August 17 Outage and the Work Ahead, the one promising better isolation and better alerting and consistent retry budgets, was published at 18:36 UTC on the 20th of August. 3 hours and 53 minutes after the critical agent task incident opened, while it was still open, it stayed open until after midnight. The post does not mention it. I am not accusing anyone of concealment. Blog posts get scheduled days in advance, and a communications calendar does not check the status page. That is almost certainly all this is. But it is a very precise illustration of the thing I have been circling for half an hour. GitHub's corporate blog and GitHub's status page were describing the same company on the same afternoon, and they were not describing the same reality. One was talking about the work ahead. The other was recording in real time that the agent product was failing again. If you want to know how a technology company is actually using these tools, do not read the post with the author photo. Read the page the lawyers made them build. Chapter 9: What would change my mind? Let me state the argument as plainly as I can, and then try to break it. GitHub's own documents, read in publication order, say this. Traffic and code volume are growing at a rate that outran a 10 times capacity plan and forced a 30 times redesign inside 4 months. GitHub attributed that growth to agentic development twice, in April and in June, and then stopped attributing it in August. Human review activity did not grow with the code. And the AI clients themselves have become a load-bearing failure mode. A retry bug in an editor multiplied traffic tenfold and had to be blocked at the network edge with a 403. That is my case. Here is what would falsify it. First, if GitHub published a human versus automated breakdown of those 2.9 billion monthly commits and the automated share turned out to be small, my whole reading of the growth curve collapses. I have been assuming the agent attribution GitHub itself made in April and June still applies in August. GitHub has not confirmed that, and I cannot. Second, if the ratio of merged pull requests to commits held steady through the doubling, then the extra volume is shipping, not churning, and under-reviewed slop is the wrong frame. GitHub publishes merged pull requests annually. It has not published them against the 2026 commit surge. If that ratio held, I am substantially wrong. Third, if commit comments falling 27% turns out to reflect review migrating into pull requests and into automated review tools rather than review disappearing, then Chapter 7 is measuring a change of venue, not a loss of scrutiny. That is a genuinely plausible reading, and I cannot rule it out from public data. Fourth, and most important, if defect rates, incident rates, and rollback rates across the software industry stay flat or improve over the next year while volume keeps doubling, then the review gap simply does not matter, and every worry in this video is an aesthetic objection dressed up as an engineering one. That is the empirical test. It runs over years and it has not been run. So let me be precise about what I actually think. I do not think AI coding tools are fake. The volume is real, it is measured, it is enormous, and GitHub is spending 3 million CPU cores and 120 petabytes of storage to hold it up. Nobody builds that for a fashion. What I think is that we have collectively adopted a metric, commits, that measures the part of software development that AI made cheap and stopped measuring the part it did not. Producing a candidate got cheap. Reviewing it, owning it, being paged at 3 in the morning because of it, that all costs exactly what it always did. And the clearest evidence for that gap is not from a skeptic. It is from GitHub's own engineering blog, which says AI pull requests eventually land under-reviewed, and from GitHub's own status page, which recorded 18 incidents in 20 days. So here is my closing suggestion, and it applies well beyond GitHub. When a technology company tells you how it uses artificial intelligence, it will hand you a number from a launch post. Take the number. But then go and find the same company's incident reports, its availability reports, its status page, the documents written by the people who have to make it stay up, for an audience that will notice if it does not. That is where a company stops describing what it sells and starts describing what it has.